Good evening and welcome everyone. Welcome to the third annual Climate Change Summit here on Nantucket. We're very excited that you are all here with us this evening. We were hoping for some spectacular summer nice weather to be outside for our reception this evening, but unfortunately it is Nantucket in September, so we will be inside today. Our theme this year is understanding local change and really getting a good community understanding of what is climate change here on Nantucket, locally, regionally, and what does that mean for us. We're really excited that this is the third year that we have done this program and it has sold out every single year that we've done it. So we appreciate the fact that the community here on Nantucket is still willing and interested to show up and listen to this really important topic and learn what we're talking about here today. We have support from our funders from the Great Harbor Yacht Club Foundation, as well as the Community Foundation for Nantucket's Remain Nantucket Fund. And this program wouldn't be possible without that support and continued support into the future, which we're really excited about. This program has been designed and hosted and put on by the Nantucket Conservation Foundation and by the Linda Loring Nature Foundation. And our collaboration on this event is part of why it's so successful and why both of these organizations are really excited not just to be doing this for the third year, but to be committing to continuing this conversation about climate change into the future. Our hosts today, we might as well introduce ourselves, and we will be speaking first this evening before being followed by our guest speaker today. But I am Dr. Jen Carberg, working with the Nantucket Conservation Foundation, and...
Hi, everyone. I'm Dr. Sarah Boyce. I'm the Director of Research and Conservation at the Linda Loring Nature Foundation. So I echo Jen's welcome, and thank you to our sponsors today.
So why are we doing this for the third year? And why are we committing to doing a summit like this into the future? The purpose of this climate change summit that we're hosting is really to bring our community together to talk about the reality of what climate change is already here on island, the change that we've been seeing and what the impacts are, but also how we as a community can get together and respond to change. So as an island in New England, we are uniquely positioned where we very dramatically feel the effects of a changing climate. We see it already in our day-to-day, but as a community, we are also then positioned to be able to figure out how to adapt to these impacts of climate change and to be an example for other communities about how you respond and be resilient in the face of change. Nantucket is a place that has, whether we were doing it intentionally or knowing we were responding to changes on climate, has always adapted to change around us. It's part of the resiliency of this island, the sand spit that's out in the Atlantic Ocean. And so getting together as a community to have a common language and discussion around understanding what climate change is, because when we understand it as a community, we can then get together to discuss how do we respond to it. How do we adapt to it? It's a change that's coming. It's an inevitable change, but how we respond to it is not inevitable. We have that choice as a community. And having this common understanding as a community means that we have a voice in being able to advocate for what we think are the adaptations that we should be doing. So that's really kind of our driver in having this conversation with everyone here. So we, again, are excited and welcome you to join us in this conversation. So I always like to start with seating everyone in the same language of what is climate change. And I'm going to preface this with saying this beginning part that I do about what is climate change, I'm going to shorten it down a little bit because our guest speaker today is also going to go into even more detail and depth in ways that Sarah and I haven't before. So we're really excited for that conversation. But climate change is long-term change in average weather patterns. You know, what's happening globally, regionally, locally, temperature, precipitation, all these things that are driving this big global weather system, the change that happens over time is climate change. There's natural cycles of climate change that occur, but there's also anthropogenic climate change. And often when you hear the term climate change, that's what's being referred to, is how us as humans are impacting what's going on in the world and causing systems to change in ways they wouldn't, except from our behaviors. And that's really directly linked to fossil fuel burning, but also how we alter the land and use the land around us. This is a graph that I like to put up. It is the concentrations of carbon dioxide levels in the atmosphere. And the last time I showed this graph last year, that red line was shorter. We have had average changes based on the past few years of what that concentration of CO2 is in our atmosphere. That has increased. There are, as you can see, natural fluctuations and variations, but it has increased as a direct result of the burning of fossil fuels, releasing carbon dioxide into our atmosphere. And as that happens, we get a change in how our system can handle that CO2 and what that does to the weather systems within the world. And you can see on one side, normal CO2 versus the accelerated CO2 levels in the atmosphere that we're dealing with. Now, it's changing patterns of heat and causing global warming to the system. And prefacing that with saying global warming doesn't mean it's always going to be hotter where you are, and that's what we'll get into some of those details, both locally and on a broader scale. As you get a change in climate, as that global mean temperatures are changing on average levels, you get changes in all of your systems on Earth. And some of these impacts are what we're starting to see locally. We might not have glaciers and ice sheets, but we're seeing changes in our sea level rise as there's changes elsewhere within our ocean systems. We're getting changes in ocean temperatures, changes in rainfall patterns, drought patterns, seasonality. We're getting changes in temperature and the extremity of temperature, not just things are warmer all the time, but we're having extremes in what those temperatures are. And then that has cascading impacts on all of the systems around us. On Nantucket, and Sarah and I will get into a little bit of the specifics on a very local scale. Climate change that we're seeing on island are these temperature changes in seasonality, precipitation, amount of timing, ocean warming. But the impacts that we're seeing day to day, storminess and flooding, erosion, which has always been an issue on island, but we're seeing acceleration in rates of erosion, sea level rise and associated flooding, groundwater rise and flooding, changes in plant and wildlife ranges, changes in phenology, changes in how our ecosystem is functioning out here. Those are the details that we're going to get into for you.
So when we talk about, Jen set us up really well thinking of global change and global warming. And when we look at temperature, we know that while we can look at global averages, we're really interested in our hyper-local, right? So like what's happening on Nantucket. And I just like to think about, I want everyone to be thinking about what you're reading, absorbing, listening to on the radio or watching on television. Thinking about the numbers are going to always be, you're going to hear lots of different numbers, and it's dependent on scale. So sometimes we're talking globally, sometimes we're talking nationally. We might be having state averages, and so kind of keeping that in your mindset too is really important for kind of some of the information that we're digesting about this. So we know when we look nationally, just looking at this map, you can see there's like a heat map of colors, and basically what this map is showing is the change in relative air temperature since 1901. So the darker colors are where there is a higher rate of temperature change in the warming realm. And so even without knowing the numbers, if you just look really quickly at this map, you can see in New England, we are warming at an accelerated rate. And in fact, since the late 1970s, the US has warmed more quickly than the planet as a whole. But then when we drill down into certain states, and specifically New England, we see that air temperature has warmed by about 1.7 degrees Celsius, so that's roughly about 3 degrees Fahrenheit. And so we're in New England specifically, but in Massachusetts, we are seeing a lot of these accelerated changes. And so I hate to say it's a great place to study some of these effects, but it's we're scientists. It's always great to study things. But we can see these effects in real time, and this is what we're seeing already on Nantucket. But of course, not only is it not uniform across the state and the region. It's not uniform seasonally either. So there's seasonal changes to these temperature differences. And so this is looking at seasonal temperature anomalies by state. And kind of the quick and dirty of this is looking at our winter and summer temperatures. Because in Massachusetts, this is when we're seeing the higher temperatures seasonally. So while we're warming, kind of at a faster rate than other places in the country, our wintertime temperatures are getting that much warmer, and our summers are getting hotter. And we really see that in, less snowfall, less, not so much ice. I mean, how many times has the harbor frozen in the last couple of decades? And so that we are actually seeing the effects of those warming winters. But we're also seeing extended growing seasons. So there's lots of different changes that come about as a result of these temperatures. And also we like to think about how does that feel to us, right? It's like maybe it's extended growing seasons, maybe it's a milder winter. But I like this infographic which came from the Massachusetts Climate Report. So of course it's Massachusetts centric. It uses really similar data, but it's showing that what our summertime temperatures feel like the historic norm, which was maybe 81 degrees Fahrenheit, our summer temperatures are starting to feel more and more like our southern states. So by 2030, which isn't that far off, we're going to be more similar to New York. I'm really sorry, go Red Sox, but we are going to be more similar to New York. We already know that Nantucket ecosystems are really similar to Long Island, more specifically. We have more similar ecotypes to Long Island. And so we're going to be getting warmer and warmer. It's just another way of thinking about how we communicate about this and how we think about what those temperatures will mean to us in our everyday lives. But of course, as an ecologist, I think of how I'll feel like North Carolina is pretty nice. Maybe by 2078, I'll feel like I live in North Carolina. But as an ecologist, I think about how does that affect our flora and fauna, our ecosystems, our migratory species? Are we going to have new pests, new species coming in? Are we going to lose species? And what about the seasonal changes? We're not going to go into all of that today, and we have in other times talked about some of these impacts, but these are the kinds of things that we think about in our different organizations and our day-to-day jobs. And in addition to our temperature, as Jen mentioned, precipitation is also changing. It's a little bit more difficult to predict precipitation changes, but what we're seeing in our area of Massachusetts is about a 15% increase in precipitation. And now when I say that increase, after the summer we've had, it's not like the precipitation will uniformly increase throughout the whole year, right? So we're not getting more snow, more spring rain, and that kind of thing. We're getting more episodic events. And so, that really can impact where does the water want to go. We know there have been significant flooding in other parts of New England and Massachusetts for sure. And I'm curious what will happen in our next significant rain event with the significant drought we've had. So we'd be remiss if we didn't mention our drought status on Nantucket. We've been in a drought level 1 since June, and then yesterday we were upgraded to a drought level 2. And what I really think is interesting is when you notice our nearest neighbor, Martha's Vineyard, go Whalers, but Martha's Vineyard has been under normal precipitation conditions. Talking to our colleagues, it's been very dry, but this is where we think about what are those hyper-local impacts. If we're only looking at state level, regional level, or national level, we're not gonna get that. We have been in a drought. We have not had significant rain since June. This is a photo of Ray's Pond, and we've had many other coastal plain ponds, kettle hole ponds that have had a significant drawdown. We've had plants go into early dormancy. Lots of fall color happened in August, and deciduous trees and shrubs are losing their leaves. Fall wildflower show has really diminished, and many flowers might not be reproducing this year. And at Linda Loring, we collect precipitation data and have since 2014, where we submit to NOAA, and we also are part of the Collaborative Rain, Hail, and Snow Network. These data are things that we collected on the western end of the island, so once again, hyper-local data. This figure just shows the gray bars are the 30-year average or the 30-year norm from PRISM, and the green bars are what we actually measured. Purple are snow, so that looks a little bit different. But basically, you can see from up until May, we've had about normal precipitation, and the 3 bars on the right-hand side, are June, July, and August, and we've been well below 40%. In fact, in June, we only had 23% of average. And so this is the kind of data that we, directly collect and have that, hyper-local focus where we can see the effects, and we're, recording the effects of the drought on the landscape. In addition to temperature and precipitation, we know that affects sea surface temperatures, which, as a maritime climate, as an island, obviously that affects many different aspects of life. I put this larger map in that shows the global sea surface temperature anomalies. But basically what we're showing with that yellow arrow is that heat map again, the dark red, shows that in our area, specifically the Gulf of Maine, is warming at a faster rate than 99% of the world's ocean. So it's warming at a 7 times faster than other parts of the world. So, and then also this is a seasonal change. So this picture is from the Gulf of Maine Research Institute, where they do a lot of work on sea surface temperatures and the effects on our fisheries in particular. And this is just for 1 year, but it does show that in that area, how that seasonal variation is really significant. And so that April, June is where it's a lot more, there's a lot more warming. And so I think about our fishery migration and what fish are available and many other aspects of, I'm sure, marine and island life that are affected by these anomalies.
Now I get to talk about sea level rise. And as an island, this is one of those impacts that we're all aware of on some level. What is sea level rise? Again, seating everyone in the same language as we talk about it. Broadly, generally, sea level rise is an increase in the average reach of the ocean, of how much the ocean comes onto the land at your highest tides. This can be a natural process of changing sea levels depending on water that's stored in glaciers, but it's being accelerated by climate change. So we're seeing changes in that rate globally, and then again, there's a local focus. So global sea level rise is the average change across the whole planet. So looking everywhere. And in 2024, global sea level was 11.1 meters higher than in 1993. And I still remember 1993. To me, I think it's only like 10 years ago, but it's not that long in a scope of time. That rate of global sea level rise was 2.1 meters in 1993, and what did I say? Meters. Millimeters, sorry. What's on the screen? Millimeters. That rate, I know, that rate has increased by 2024 to 4.5 millimeters. That's a significant increase, and that's that rate of change that's happening. So not only is sea level rising, but the rate that rise is happening has been increasing over time. They do an average as they create it, and it's usually a 30-year span of what that rate is. So as you gain more time and look at that, it's that rate. But that's the rate we're seeing today that's changing when you compare back. Is millimeters per that 30-year cycle of time. So when we were looking at it back in 1993, they would average out that rate at 2.1. Now that we have all this data of change, they've averaged it out, and that's the rate going forward. So then on a local level, we have very local data from our local tide gauges that can tell Nantucket what it looks like, what is changing with sea level rise. And that's influenced, what that number is influenced by local landforms, local land use, what's actually happening here on the land where that water is going to move and go. And we'll look at some flood maps as we go through. So this is the very local data for Nantucket. This is the NOAA sea level rise projections. This was updated in 2022. A couple of years ago when we gave this presentation, we were using this graph from about 7 years before that. We had new data that was averaged into this, so these models are more accurate over time as we're measuring more sea level rise over time. What you're seeing here, it's in meters of change, but then the numbers on the side here are actually in feet, because sometimes that's easier for us to grasp and understand. There are multiple lines here because it's based on what the scenarios are and projections for climate change that's driving sea level. So as we think about what's going to happen into the future, We look at different rates of that climate change estimate, how much carbon dioxide is going into the atmosphere. Do we do really well as a community and change our behaviors so we reduce the amount of carbon dioxide that's going in, or do we just burn all the fossil fuels and go to that high level that's up here? So that's why there's multiple lines. We have the historic line of what's changed, and then looking forward to the future, what are those impacts gonna be? The 6.6 feet is the highest scenario. We go down to the lower scenarios, we're at 2.49, that's by 2100, so you can see the change over time. Takeaway from this is that we're going to have change no matter what. We've reached a point where we are going to continue to see change no matter what our behaviors are, but thinking about a community, what can we do locally that can help us influence what happens here? It's also information that can help us adapt. And the sea level rise numbers deal with, this isn't storms with the amount of water that we're talking about, it's that mean high tide every day. So we have a graph here of the Whaling Museum in 2100 using the intermediate high scenario, a projection of what that water level would look like on an average day during a high tide. And you can see that it would certainly impact how we move around the island to have those kind of high tides every single day. What are we seeing with storminess? So there's a perception that we are seeing a lot more increased storms, hurricanes particularly, but also here, nor'easters are one of our bigger storms that we see impacts on the island. And what the data is showing us is that there's not necessarily more storms that are forming, but there's more storms of note. Storms that leave an impact that we remember as a community. And so this picture here is of the Land Bank Park down on Easy Street. There's actually a graph that shows the height that water was in town on different storm events that happened. And these were storms of note and things that we remembered. We are having more of those storms of note where we see impacts, where we have kids that are out canoeing down, during a middle of a storm in winter, where we're seeing this water and it's having an impact on how we function as an island. This map comes from the island's Coastal Resilience Plan, which is on the town of Nantucket's website. I encourage everyone to check it out. There's a lot of amazing data in there and also solutions for things that we're planning for to adapt our island to be more resilient. This is a map of flooding, and these are the areas on island and how the chance of them flooding in a 100-year storm. Dark blue is in 2030, and then the lighter the blue, the farther we move in time. The thing to point out is that this initial map is where things flood, potentially in a 100-year storm. When you add sea level rise on top of that, and you look at this graphic at the bottom, we have coastal hazards. We live in a coastal area. You add sea level rise on top of that, and the impacts that we feel are going to be even stronger. That reach is stronger and wider. We don't just have sea level rise with water coming up with those daily high tides. We combine those tides and we combine storms together, and you get a wider impact. And so you can see over time, 2030, which is only 5 years from now, 2050, 2070, what that changes in areas that are impacted across the island. The percentage of structures, roadway service, protected open space. And you might look at this and say, okay, well in 2030, it's 15% of our roadway is impacted. But think about what roadways those are. Easy Street to get to the steamship wharf, Pulpus Road at Folgers Marsh, out in Nantucket, near the dump, Millie's Bridge. Like, these are roadways that are extremely important for access and movement around our island. So yeah, it's only 15% of the roads that are on island, but there are roads that are key to how our island operates. Another thing that we're really just starting to talk about, and honestly haven't actually modeled out for the island yet, is that we're going to see an increase in the reach of our wetlands on land, potentially in places that we don't expect. And that's due to rising groundwater. So I apologize that this is Cape Cod, but we have a very similar system out here, and I don't have a great graphic for Nantucket. Someone can make one for me, that would be amazing. But we have our fresh water, our aquifer, and our groundwater underneath our island. Under that is sea level, or is salt water. Salt water is denser than fresh water, but as that sea level rise happens, as we're getting pinching near the coast as that salt water pushes up, it's also going to push that groundwater up from underneath. And so if you look at this diagram, you can kind of see the lake. We've got a water table here. Water table is the distance of groundwater below the soil surface. As that groundwater rises, it means those areas adjacent to your lakes, your wetland areas, will spread out. More areas will be wet than had been before as that groundwater rises over time. This is not the best map, but it's the only one that I have. The darkest oranges show groundwater depth, and this is 2021, groundwater depth below the soil surface. So you have your soil, and then you have your groundwater somewhere below it. Where it's at 0, you have a wetland or an open water body. The darkest orange is 0 feet below, so that's where we have open water. As you get to kind of the light orange that's there, that's groundwater that's 2 feet below the soil surface right now, or a few years ago. What we expect in the next 30 to 50 years is a 2-foot rise in that groundwater. So places where groundwater is currently 2 feet below the soil surface will be wet, will be open water, will be a wetland in 30 to 50 years. And again, we don't have enough data to be able to track exactly what's going to happen. The other key point is that groundwater rise is actually predicted 3 times farther inland than sea level rise. So if you're looking at your sea level rise maps and saying this is where water is going to come, there are farther places inland that we need to pay attention to for where the water is going to go. And the last bit I have here is on erosion. We know erosion is a huge issue on this island, always has been because we're an island made of sand. I want to point you to the town's erosion monitoring program that they've had in place. You can see the website there if you want to go look at this data for yourself. But there's monitoring that's been happening. This graph just goes up to 2024 because that's the data I already had pulled. We're looking at Tom Nevers here on the South Shore. And from 2021 to 2024, there's been an average loss in 28 feet of that shoreline. That's the erosion that's happening over time. You can see that there's occasional pulses or places where monitoring stations originated that have disappeared because that erosion has occurred. This one here is the sewer beds, and we know that the sewer beds have been a hotspot in recent years. Same time frame. There are more stations here, but the change over time is 99 feet of erosion from 21 to 2024. And then if we go to the North Shore, much less change, a loss of 3 feet over that time. We know that our North Shore is less dynamic in that we don't get the same storms, but when we do get them, we can potentially have larger loss. So this is a map that comes from the Coastal Zone Management Program of Massachusetts, and they look at aerial photos and mapping going back to the 1840s. This is 1840 to 2018. And you can see that pattern that we're collecting with very local data backs up what's happening in this mapping that we've seen over time. The red is loss, the green is growth, so areas of deposition, so erosion, deposition. Yellow is where things kind of stay the same, erode, accrete, back and forth over time. So our South Shore is obviously the place that we are losing the most. We still have it on the North Shore, even if that degree of erosion is not as great. We do have areas that we are accumulating sediment, where sand is being deposited and we're growing space. Brant Point, Eel Point has places, the Hullover within the harbor itself. But the thing that I want to point out is those areas may be growing, but they're growing with unconsolidated sand with nothing holding it in place. So areas that have vegetation in place, you can see back in the foreground here, those are extremely resilient shorelines where you have shrubs, where you have grass growing, where they're holding those dune systems in place. That gets eroded and deposited somewhere else on island, but it's deposited as loose sand, which means the next storm that comes through is just going to take that away again. It's more easily moved, more easily eroded. So thinking about that map and that change across the island, those are the erosion patterns that we're seeing on island, and figuring out what are the ways that we can adapt that through capturing sand, innovative techniques, through planting grasses. Like there's ways to mitigate this when we know where to look for restoration.
So we don't like, if you've heard Jen and I talk before, we don't like to just all be like, everything is terrible, it's gloom and doom, and then just, leave the podium. So we just want to ensure everyone that the big we as a community, we are doing many things about addressing climate change impacts. And that's, as Jen led with when we first started, one of the reasons we hold this Climate Change Summit is to have everyone in conversation. It's not just us, although we love to take all the credit, but it's everyone in the community at many different levels, many different organizations doing different things. And so, we both work for conservation land-based organizations, the Conservation Foundation being the largest landowner, Linda Loring being out on the western end, but both lots of different diverse habitat types. And so this isn't specific just to us, but many land trusts in general work towards resiliency in many different ways. So first off, we record and research the effects of climate change. So how are these, temperature and water anomalies affecting our flora and fauna? Both organizations and many others on island have been protecting rare species for a very long time, but how we protect those rare species might change with impacts of climate change. We have always been about protecting biodiversity, and we know that more biodiverse and more diverse habitats are more resilient to change. So it just puts another lens on that increasing biodiversity effort. We can reduce further stressors. So we might not be able to do something very directly about sea surface temperatures or, springtime or wintertime temperatures, but we can reduce other threats, reducing inputs to our waterways to help reduce harmful algal blooms. We can remove non-native invasive species. We can reduce further impacts to our properties. And then our open space can be space for mitigation. So whether it's our freshwater or saltwater wetlands that are functioning and holding water and releasing water after storm surges, or just our open space that can take on some of this, the impacts and be a buffer between, built environment and important roadways, for example. So we can think about our conservation spaces in many different ways. And then events like this, we can provide education and outreach so that we can be a more resilient community together. And it's not just us, there's many different organizations, including our municipality as well, that are working on these issues. And I'm not gonna go through this list, but these were just some of the things that we were talking about, where our many different organizations are working some very obvious kind of climate resiliency or coastal projects that are directly dealing with impacts, but many of our projects and the work that we do are still within this lens of climate change and coastal resiliency, and kind of dealing with the stressors that come with the impacts that we're seeing with coastal change. And so a lot of it is just communication about all these things. And so you might hear this over and over again with many of our different organizations, but I think lots of the things that we do are about addressing climate change impacts. And I also wanted to say at this slide that we have some posters in the back from our organizations and our colleague organizations that are highlighting specific projects that people are working on. So I encourage you, especially afterwards during our kind of social hour, to take a look at some of the projects, ask questions. A lot of things are in process and in progress, and we might not hear about them until things are completely done, but there's lots of things that are in action, I will say. And people always ask us, whenever we give talks, like, what can we do about that? So first of all, attending events like this helps make an educated public. We can share this information about what impacts are happening on the island. Participating in conversations, whether it's at the neighborhood scale, the island-wide scale, participate in these discussions. Adapt your own properties, businesses, if you're, or if you're a landowner. There's many different local options, whether it's on the Coastal Resilience website, the Coastal Resiliency Plan, or at the state level, there's, the Coastal Hazards Handbook. And I think mass.gov has this great, everyone can take climate action. So different ways that we can all maybe change some behaviors or do small or big things to help combat the problem. So I encourage people to kind of look at all these different things that are available. And with that, Jen and I would love to thank everyone again for coming here. Our contact information is up here if you have specific questions for us. We're going to hold questions right now for us before we introduce Bernadette. But I also wanted to point out the Climate Summit website, which is acclimatesummit.com. We have some information from our previous summits as well, and I know on both of our organizations we have last year's summit that was recorded too. So if you want some more in-depth information on specific impacts or ways that we are adapting, there's more information too from both of our organizations and on the Climate Summit website.
And we are recording this today, and it will be posted on this website in the future. And in a few weeks, we're having NCTV record it, so once they process it, you can go back and share it with your friends as well. Absolutely. Okay.
All right, thank you. Thank you, everyone. Well, now is for, I'm very excited to introduce Bernadette. This year, we are very honored to have Bernadette Woods Placky of Climate Central join us. Climate Central is a policy-neutral nonprofit whose mission is to communicate climate change science, effects, and solutions to the public and to decision makers. Bernadette is Climate Central's Vice President for Engagement, the Chief Meteorologist, and directs the Climate Matters program, where she helps the public understand the importance of climate change science, impacts, and solutions. And so please, everyone, help me welcome Bernadette as she talks about from storms to shorelines, connecting water, weather, and climate change. Thank you.
Thank you, ladies, and thank you, everyone. I mean, look at this packed room for a climate change conversation. I love it. This is my first time in Nantucket, so thank you for having me. It's been wonderful, and I get a little more time tomorrow, too, to explore, so thank you. All right, so I'm going to cover some of what they did, but in some different ways, and we're going to go a little more in depth on the weather side of things here, too. And a little more about Climate Central. We really do our science for communication purposes. We take on various projects and programs with the goal of trying to help people understand what's going on and moving that forward. And so I've been with Climate Central about 12 years now. First half of my career, I did television and operational forecasting. So I've been with Climate Central 12 years now, and I've had a real great opportunity to connect with so many people and really have these conversations, and this is what gives me energy. So thank you very much for coming, because sometimes it's a hard subject, right? It can be pretty depressing when you're talking about how crazy the weather's getting. So this gives a lot of hope here. So we're gonna get through changing weather, rising seas, so a little bit more on what they were talking about. Attribution science, and for those who aren't aware of this, really new cutting edge science diving into specific weather events. And from the science side, it's really fun. And the power of communication. And this is a solution that all of us can take with us as we leave today. So, just to ground the conversation here too, most of you know this, but it's so important to start from this level. The reason we know the climate is changing is because of science from the 1800s, the greenhouse effect. The blanket that's wrapped around our atmosphere that traps heat because of specific gases. And we know that we're adding more of those. We already saw that in their graphic. Now, where's it coming from? Now, I do break this down. This is from the EPA, breaking down the US version versus a global version, because as they were saying, we hear a lot of different numbers, and one of the reasons you see different numbers is because it's a little different in the US versus the rest of the world. So our leading form of greenhouse gas emissions in the US is transportation. We drive really big things really far in our country. Most of the world doesn't do that quite the same way. Now, on the reverse, we have managed agriculture in our land slightly different than the rest of the world, where we're taking down Amazon and Indonesia, big rainforests. So that's some of the difference you see there in the numbers, but these are the sources. And sometimes people know some of the sources, but not the full picture. So it's really good to see it put together. This is what leads to our warming. Now, as we add more of these gases, primarily carbon dioxide, but also methane and others. There's a direct correlation with temperature, as we know, and I highlighted this because it's in Celsius only because it's global. But we know, we speak in Fahrenheit here, 2.7 Fahrenheit. And this is notable because for those who follow along with the global conversation, the Paris Agreement has a goal of limiting warming to 1.5 degrees Celsius. Now, that's an average over 20 years or so. This was a one-year snapshot, but last year we hit 1.5 Celsius. And we saw what that meant around the world. There's a lot of damage, a lot of big storms, a lot of sorrow and heartache. And so that's what happens when we add that warming. Now, what is a degree, right? A lot of people are like, so it's a degree, right? Here's this bell curve, and let's take you through this. For those who don't look at bell curves all the time, it's our distribution of temperatures under that curve. And you see initially, cold and hot. A slight shift in the average. Look how much more red we get. Now you still get cold, and we're still going to get cold. We're still going to get weather. But look at how much more red there is. So that's what we're shifting. And it's putting us into a whole new climate zone. And this is how it plays out. Here in Nantucket, we are seeing those temperatures rise, our highs, our lows, our averages. And I did a snapshot of some other ways to look at that around the region. Now, at our program, Climate Matters, we have all of these resources. I'll have the link at the end. Anyone can sign up. They're free. You're welcome to use them any way you want, or just get them, because it's a weekly package of communication resources that we put out. So, have at it. Hot days. They're getting hotter. And when you're looking at those extreme heat days, that's when you have to rethink life, right? That's when cooling centers have to open, camps might have to change, sports practices, all of that. Nights, they're not cooling down like they used to. That plays into energy bills, and that actually plays into health too. More risky, humid heat. So it's not just the pure temperature, but that overall moisture level that's coming up too that doesn't allow your body to sweat and cool down. And another way of looking at this too is records. Again, still cold records. That's the blue on the bottom that you see there. And on the top, those are the record highs. So yes, we still get record cold, just not as much. And the reason you see it in the news when it happens is because it just doesn't happen that much. There was an event a couple of winters ago, huge outbreak of cold. People all along the shore in Chicago, record cold, record cold. And it was record cold. Everyone was gone 4 days later when it hit a record high. So that's the thing, is we just don't get it as much, so that's why it pops up in your news. Another way of looking at this, and they tapped into this, but we did an analysis that looked at cities, because sometimes some of the western states, it's harder to get a full growth of that change. So when we broke it down by cities, looking forward in time, a couple of degrees would put a Boston summer feeling like a Philadelphia summer. And I know it gets into the baseball thing, which I have coming up too. So that's the temperature side of things. But it's also supercharging our water cycle. And this is something that gets confused because people say, well, how can it get drier and wetter at the same time? That can take a minute to process, right? Well, this is how. When you look at the water cycle, you have the evaporation side, then you have the precipitation side. Rain here, it can also be snow. And remembering that most of our globe is water. It's easier for people here to remember that. When we're doing conversations in the middle country, sometimes people get disconnected with that. But we have so much more moisture being evaporated into our atmosphere. So when there is a trigger for it to come down, a storm, a front, whatever it might be, it's coming down in bigger buckets. And that's overwhelming our systems, our infrastructure, our roads, our bridges, our sewer systems. The way we've created our societies based on a different climate. So this increase in how we experience it isn't landing well. I mean, we've seen the pictures from New York City with the subways just rushing water down. So with rain, they hit a lot of the stats for the Northeast. I'll show you a few more here too, is just that more evaporation, that more moisture in the air on general, and again, this was a global one, but in Fahrenheit, about 1 degree Fahrenheit is about 4% more moisture that's actually available in our atmosphere to come back down when it does. this is a snapshot from the country, and this was from the most recent National Climate Assessment, which was a congressionally mandated report that was put out. You see the biggest increases are in the Northeast. Now, even in places that are getting drier overall, the way we're experiencing rain is changing, and you see that across the Southwest. It's headed to drier, but when it happens, it's coming in these bigger downpours that, again, are overwhelming systems. And if it's drier to start, then that does not get absorbed, and it creates flash flooding, and then it's not always usable water, too. So here's a snapshot. We didn't have the specific data for Nantucket, so all these numbers are slightly different. You see Hartford, Springfield, Mass., Albany, Concord, New Hampshire, but they're all going up. What you're looking at is those highest rainfall days in those hourly rainfall data when it just comes at you. And I live in New Jersey. Ida, a few years ago, old hurricane that moved up that many of us experienced, right? There were over 3 to 4 inches in an hour of rainfall. So again, that may not come up in your averages, but that led to a lot of deaths on the road. So that's how it's being experienced. So on the other side, the evaporation side, right? That hotter air forces more evaporation. So when it does start to dry out, it dries out more and faster. And that sets the stage for a lot of different things we see, including wildfires. And the biggest increase we're seeing for those fire weather days, and these are those days where it has this doesn't mean all fire days, but when the conditions are there. It's the hot, dry, windy days when all of those pieces in the recipe come together. And there's a huge increase across the West. There is an increase across parts of the East, too. It's not as big, but we've all seen firsthand over the past couple of years that wildfire smoke does not stay where the fires are. And then it travels across the country. And that is a health hazard. Thunderstorms. Now, severe thunderstorms has a specific definition in our meteorological world. It means a thunderstorm of, very specific though, 58 mile per hour winds or higher, hail 1 inch or larger, and or a tornado. And the way we're experiencing severe weather, still earlier research, for the tornado side, it's more that tornado outbreak days when we had multiple tornadoes on a day seem to be shifting and increasing. It doesn't mean more tornadoes overall, but when those conditions come together, they go. And also the seasonality and the geographic distribution. So what used to be Tornado Alley is migrating east across the country. And what was tornado season in some of those areas, it's creeping in more into the spring and into the winter and into the fall. And so this is a changing risk conversation, because if you're in Iowa or if you're in Oklahoma and you are used to a thunderstorm in May, you know what to do. You just intuitively react. If that happens in January, you do not react the same way. You do not go to the storm cellar the same way. And that's what we're starting to see. Now, also with the rest of the severe thunderstorms, some earlier research on the wind portion of it, and it seems to be that there's evidence that when we have a severe thunderstorm wind gust, those damaging winds from severe storms, that there is an increase with a higher temperature. It's hard to get the data on hail right now. All signs are pointing to that there is more and larger hail. This is one of those where data, is public or private. There's a lot of data out there in the insurance companies, and we're seeing more and more insurance claims with hail, but we don't really have an analysis on that quite yet. So that's just the atmosphere. The vast majority of the heat is going into our oceans. The first time I saw this years ago, I was just blown away. 93% of our extra heat is going into the oceans. Only 7% in our air, and all of those changes. So this is playing out in some big ways, right? One being the hurricane side of this. Warmer water fuels storms. It leads to a storm growing to a higher intensity. It also leads to rapid intensification. And that is another changing risk conversation. Because if you're in North Carolina and you've got a Category 2 there are certain areas that you evacuate. If overnight that 2 becomes a 5, your evacuation is very different, and some of those barrier islands take 72 hours to evacuate. So you can't just change that. So we're seeing more intense storms when they happen, not necessarily more storms, and also that intensification happening more rapidly. When they do make landfall, they're coming with more rain, as we saw with Helene, and a higher storm surge. And they got into that piece of the sea level rise just going that much farther inland and that much more damage. And this is really building up. The number of billion-dollar disasters, which is a high bar, and this was all NOAA data, and it was adjusted for inflation. This data set was shut down. We actually, at Climate Central, I have to say, we were able to just hire Adam Smith, who ran this data set. And so we are bringing it back, which is really exciting. Thank you. We're excited too. But this was the latest complete data set, and it was through 2024. And you're seeing that there are just more of these, and they're happening more frequently. So this is the time in between disasters. When this data set was started in 1980, look at those. On average, we took a chunk of, I guess it was maybe 5-10 years. On average, it was 80 days between. Now, it's about a dozen. So again, how that stresses our systems, our emergency management, our FEMA, our Red Cross, all of the systems we put in place to respond to these events are just being overwhelmed. So it's constant response, no preparation, and that's where we are. Now, this is playing out in so many different ways. I just put a couple other slides out here. Our health is a big impact from our changing climate. We're getting more mosquitoes. They're spreading poleward, and new kinds are creeping into new areas. And so that's a concern. Our allergy seasons, yes, we have longer growing seasons, but that comes with allergies. And we're also seeing new types of pollen migrate into new areas, more and more poleward. You know, it loves carbon dioxide. It's poison ivy. Exploding. And then all of the air quality issues, one being wildfires, but also when we have more heat, it creates, in stagnant air masses, it creates more ground level ozone. And that's also another air quality issue that we're seeing. Now, our back to school cooling demand is on the rise. A lot of schools were not set up for air conditioning, so we're seeing that around the country. More power outages, weather-related power outages. Some of our nearest and dearest things, wine, beer, these are being influenced. And then I didn't want to get into the Red Sox-Yankees thing, so I put the Phillies, since that's my team. But it's affecting a lot of our sports too, from our football seasons into our youth sports. There's a really interesting group of people trying to bring some logic and reason to when we have World Cups, the time of day that we have some of these games, or with these Olympics, trying to shift maybe marathon start times, triathlon start times. I mean, it's really taking a big toll from the big all the way down to our kids. So back to our oceans here. We've been pushing records the past couple of years. Like, it's really extreme with how warm our oceans have been overall. And we already covered a lot of this, so I'll move through some of these quicker, but rising seas for Nantucket at this gauge, and this was data I got from the website they showed you, 8.7 inches already from 1950 to 2023. This also is just incredibly notable, right? Sunny day flooding. When it creeps up onto Easy Street, outside of any storm, from 1965 to 72, and again, these years were on that Nantucket.ma/ma.gov site if you want to explore this, but it was 6 days on average. It's a nuisance, right? Fast forward, 2013 to 20, 37 days, and in 2023, a record of 75 days. That's 2.5 months, right? It's a lot. And if you want to explore some of the maps they were showing, I'll just step through here. Climate Central has a really robust sea level program. If you go to our website, Coastal Risk Finder, you can explore a lot of data of what will be underwater, different years, different scenarios. And a lot of the scenarios, the reason that climate models have a range is because we can predict our atmosphere and our climate better than we can predict human behavior. And so you have to take this range of scenarios. And quite honestly, the lowest level, there are scientists who don't even want to represent that anymore because we're just running so far above it. So just when you look at these, consider that. And so if we take an example here, and I kept the left-hand side, so if you want to explore later, I can kind of take you through that. I'll step you through 2050 and 2100. This would be sea level rise, and a general moderate sort of current commitments where we are right now, well, where we were last year, and you add an annual flood. Just on average, what would be a normal flood every year statistically. You start to see the reds where that's popping up. Take you out to 2100. They go in a little bit more. It's hard to see on the zoomed out version like that. So that's why I just wanted to give you the info so you could go explore it yourself and you can look where you live. Take you in a little bit closer here, and I couldn't go through the whole island, but this is the same thing at 2050, then 2100. That's annual flood plus sea level rise. And again, there's so many different things you can play around with this site. It's kind of overwhelming. Sometimes there's a lot of stuff on there, so you can explore with a lot of visualizations, mapping tools, and data. So that's a summary of that part. Now, I'm going to shift a little bit to not just the general trends we know with our changing weather, but some more specifics. And this is fun sciencey, so we're going to get a little geeky here. Extreme event attribution science. Now, general attribution is what developed in the 80s and 90s of how we could make those connections of climate changes is connected to these general trends. In 2003, there was a heat wave in Europe, and the estimates really range from between 50 to 90,000 deaths. Big one, really big. And there were some scientists, Stott, Stone, Allen, at Oxford, that went in and analyzed this event and were able to tease out the role of climate change in that specific event. It has to do with our climate models, our historical data, and you can go in also in the models and play around with different layers and levels of carbon dioxide and how much can you recreate this? Can you recreate this? What does that look like? And you put all of this together, and this is how you can tease out how much climate change affected an individual event. And the narrative used to be you can't attribute any one event. Well, that changed in 2004 when this came out. So it was a 2003 heat wave, changed in 2004. And so since then, this has been a really rapidly advancing branch of science. The Bulletin of the American Meteorological Society was putting out special issues on this, and they started in 2011, and they were doing annual issues, a collection of all these attribution reports that were popping up. World Weather Attribution, still active today. We helped start it at Climate Central. We've shifted our role, and I'll get to that in a moment. But a group of scientists that go into individual events, they are putting out so many attribution analysis. It's really amazing. You can go to their site and explore, and they're global. And they don't just get into made this event more likely, this much stronger, whatever it might be, but they are also getting into the vulnerability, the exposure of what is at risk. And then the National Academy, for those who don't follow along, they put out this consensus report, which is big for the National Academies. When science gets to a certain point, they do this consensus report of where are we in the science, what can we say, where is it, and sort of give that gold stamp. They put this out in 2016. They said, yes, we can contribute these in these ways. And this is actually continuing to advance so quickly that they are doing a new consensus report right now. Because where this is playing out is not just in weather, not just in communication. It's also playing out in a lot of the litigation you're seeing with all the climate lawsuits that are popping up. This is one of the reasons. It's also playing out in the loss and damage conversation globally. And so it's a really fascinating area to study. So at Climate Central, we don't do the litigation side, but there are some amazing people doing this. And Columbia has a law center that does a ton on this too, really trying to bring together the scientists and the legal minds in moving this forward. The other thing too is there's this impacts attribution. We're right on the early days of methodologies of how much economic impact that caused, or health metrics, specifically from an event. So it's really advancing rapidly. So Climate Central, one of the things, this is a quick summary of our confidence level too. So on the bottom, these are the two things that go into where we can go with some of these attribution statements, right? So on the bottom, reliability of observations. We need good data. We need good data. And when you get to thunderstorms and tornadoes, the data just isn't as comprehensive and it doesn't go back as far. Also, we've updated how we report tornadoes several times over the past 40, 50 years. Fun fact, like we couldn't even say tornado in a forecast in the 1950s because it was assumed that we didn't know enough and we were just scaring the public. Like that's how far tornado forecasting has come in that time. Knowledge of causes on the left, that's also that how much do we understand? So that's why you see heat and lack of cold super high. There's a lot of data, a lot of knowledge. When you put more heat into the system, you get more heat, you get less cold. Pretty simple. Precipitation, it really comes back to what we showed you. And then it starts to drop off a little bit, but still, this has gone up somewhat on the hurricane side, the hurricane intensity side. That has increased over the last couple of years. And the flood and drought piece, the drought one has gone up considerably. The flood piece, there's that human component too of we can assess the water coming down, but the engineering component of where the water goes, when, and how isn't always pulled into an attribution report. So that's why it's a little bit down there. But this is, again, I'm going to take you through another bell curve just to show you how we've approached it. At Climate Central, we now have this climate shift index. It's on our site. I'll show you. And we've shifted some of the methodologies, applied them so that we can look at temperature everywhere, every day, not just those absolute extremes, because this is where we're working with world weather attribution. They're going deep into those absolute extremes. That random 80-degree day in April that's not going to get a report, but we know something's weird. We have that now in our system. And so you can go to check, is this normal, and really get that answer. And so what you're seeing here is like we've warmed generally about 1.3 since the pre-industrial era. So that's already shifted us a little from if we took down to, I mean, we're not going to get rid of all carbon dioxide, but you can shift it a little bit in those climate models just to play around with these scenarios. And so that would give you a 0 if it was just kind of an average day, even from earlier times. But then you start to see on this scale, a 1, a 2, a 3, a 4, a 5, the more on the right, showing that climate change played a role in events that are on the scale that 2 times, 3 times, 4 times, 5 times more likely. We also did it on the other side. And I'll show you this map from today. Today's actually less likely. So you're not going to get days like this very much in the future with our warming planet. And so we really brought this in. And what we see over time is there's just not as much of that gray, and there's a lot more of the red when you look at this map. And so I'll take you to a snapshot of today. And again, I showed you this view so that you can go, you can play around, you can click on things. It's all on the left there. And this is just a snapshot today around the world where we're seeing things more and less likely. Then I brought us in a little bit here to show in the United States, on the East Coast right now, these days, enjoy them because we're just not going to get as many at this temperature range in the future. Now, out west, you see that, well, LA has gone back down after the front went through, but you're seeing over the Southern Rockies and down into Mexico, and there's a lot that we always see around that equator belt that is just so much more likely because of climate change. So this is a direct fingerprint because of all the calculations and all the data in that daily temperature. Now, we've done it for ocean too. The crazy thing you might notice is that scale is so much higher because there's so much more warming in our oceans. It's kind of blew my mind a little bit when we were pulling this together. And this is a snapshot from a couple of days ago. And you see, the oceans are just really hurting right now. We're pushing them. And so just to bring in a little closer, this isn't the long term that they show, but this is the looking in early September, the role of climate change in what we're seeing out there right now. There's still an influence. So that plays into hurricanes, right, is one of the things. And Erin, we were just talking about Erin. And it experienced rapid intensification, really rapidly, pretty wild. Fortunately, it was far out to sea, but we all saw the effects come up and down the entire East Coast. And you see, it was at least the water that it moved over was at least 90 times. The climate change influence was at least 90 times more likely. So that was the direct role of climate change in those water temperatures it moved over to cause that explosive intensification. And it was still so far offshore, and look what it did, up and down the East Coast. And then this was one from last year with Helene. It moved over water when it exploded. It was 300 to 500 times more likely because of climate change. I mean, that is just wild. That's why it captured so much water and did so much damage inland. So all of that, like them, don't want to just be like, sorry, how do we move this forward, right? And so they covered so much amazing stuff going on here, way more in depth than I can. I've been so impressed by what this island is doing and how collaborative you all are in working together, because it's so critical. I mean, we have to move forward. We don't have time to wait. So it's so amazing to see people working together in such smart ways. Another thing, though, that we can all take with us is communication. Use your voice. Have conversation. Ask questions. And I'll show you a couple of things here. You know, this is, for those who don't know this is pretty fundamental research on climate communication. And it goes back to 2008 from our friends at Yale and George Mason. They've been taking a survey twice a year of the American public. It's actually expanded to many different countries. It's climate change of the American mind. And they've broken down the category of where people are on this issue across the United States. And what you see is there's so much more on the left-hand side there. Alarmed, concerned, cautious. The dismissive, this 10%, has been allowed to drive the narrative a little bit too long. This is the group that aligns with a lot of political conspiracy theories they found in their research. You're not going to change the mind of that 10%, but if you let that drive the narrative and your conversations, you're missing 90% of the population. And I see so often, to me, the biggest piece of misinformation in climate change is the communication on this. We think more people don't care. They actually do. So if we engage in our conversations thinking and knowing people actually have questions and care, even when they come at you with that, like, is it real? They're engaging in a conversation. So a lot of people just really want to learn about this. So that's how we should start those conversations. Now, this is how it's broken down across the country. And they put these in the Yale Climate Opinion Maps. Again, you can go to them. You can explore. Across the top, that bar has 28 questions. Really cool stuff you can get in detail. It's from, they use the word beliefs. I don't like to use the word beliefs with science, but different views on climate change. Then they get into policy issues. I mean, it's overwhelming how many people want wind and solar. I mean, it's 70, 80% across this map. And so this is a real snapshot updated twice a year across the country. And so you can go deep on this. On the right-hand side, once you drop below the yellows, you get into the blues. That's 50% or lower. And if you look at that, it's hard to see all the different counties, yes, but there are very few blues, very few. So this isn't just a red versus blue. People know the climate is changing. So that is how you need to engage in conversations, questions, things like that, is knowing people actually are interested. This one I always love to show. It is estimated percent of adults who somewhat or strongly agree that schools should teach causes, consequences, and potential solutions to global warming. 77%. All of these wars we're having with school right now and books and everything, this was from late fall, right after the election, and still see that. To me, and I've talked to Ed and Tony, who run this research many times. I've been lucky enough that they've been my collaborators since I've been at Climate Central. This shows you that people know something's happening, but they don't know what, and they have questions. But percent of adults who discuss global warming occasionally with friends or family. And in their research, the most trusted messenger is your friends or family. Climate scientists are right up there. Most people don't know climate scientists. TV meteorologists are right up there. This is why we've worked with them to help them understand and bring it in ways that make sense in their broadcasts and online and all their digital work too. 36% How have we ever changed anything as a society if we don't even talk about it, right? You don't get movements, you don't get progress. And this could be from talking to your friends and family, this could be asking questions to businesses, corporations, simple things. Where does my food come from? Where does it go? Where does my energy come from? Where does it go? There's so many conversations we can have or questions that we can ask to just raise our voice and start talking about this. And this is something everybody can do when you go out of here today. And to get started, here's some of what we have learned in our experience at Climate Central to guide this process. Know your audience. Golden rule of communication. That means topic, tone, timing. You know, just you want to engage with people that way. Meet people where they are. Connect on shared values. We've gotten into baseball. Lots of people like sports. Lots of people. There's a lot of things that we do like together. We keep focusing on what divides us, but there's actually a lot of stuff that brings us together. Our kids, our communities. So meet people where they are. Personalize, localize when you can. And the more you get to learn, I mean, not everyone's coming to something like this, but not everyone wants the jargon. Not everyone wants the scientific terms. This is something I have to tell our community, and we train a lot of journalists. They do a beautiful job of learning, but then I'm like, don't use those words in your actual story. Like nobody cares. No, you're gonna lose them. You're gonna lose them in that process. So simplify, drop the jargon. When you can tell stories, this brings people in. Now that's not for everyone and not every situation, but the biggest one is don't be afraid and don't overthink it. You have science, you have public opinion on your side, and people actually wanna have these conversations. So here is the QR code, or you can go to that URL, climatecentral.org/climate-matters. There's my email. Reach out at any point. And this is a way you can sign up for, I mean, it's weekly stuff, or you could just go to our website under our resources tab. We have a lot of stuff. It's actually kind of overwhelming, and we're working on trying to update the website. So it can be hard to find some things sometimes, but you know, you can always reach out to me and I can help you with that. These are things just to build knowledge, build communication, figure out how things are being affected in your lives by our changing climate. So I'll leave this up for one more second here because I still see people taking pictures. Okay. And I just wanted to wrap up with this, that this is our atmosphere. This is it, this little sliver. That's it, right? That's it. It feels so big from down here, but it's not. And this is what determines human life on Earth. And we have a choice going forward. We can still keep things in levels that we can adapt to. That is really up to us. So our future really is our choice. So thank you so much for coming, for having this conversation. I really appreciate it.
Bernadette, thank you so much. That was wonderful. Part of our purpose here is not just to learn from the people that are up on the stage, but to start to have this conversation together. So we have time now before we move to our open session in the back, but we have time for questions. Questions for Bernadette, for Sarah and I, things that anyone has been thinking about that we here as a community can talk about. I have an extra mic that I'm going to pass to Giseline here. So if you have a question, please just raise your hand. Shelley's got a question.
Hi. So I've been to a few of these, and I've heard numbers of times about the Gulf of Maine, right, and how dramatic the temperature is rising in that particular area. So between New England and that water, why there? Is there a specific reason? I know the Gulf Stream, anyway, I don't want to confuse the answer, but the Gulf of Maine comes up all the time, and New England comes up a lot. And do you know why?
Well, some of it is where is the data? Who is collecting it? Who is analyzing it? The Gulf of Maine Research Institute is a wonderful organization that does a lot of work in that space. So there's a lot of, and you can completely correct me, Bernadette, but we, like Jen and I, tend to talk a lot about the Gulf of Maine because there's research very specific to that region, and we are in, Nantucket is part of their study region, and so that is I would say kind of like the local as we can get for all the different ways they are looking at those data. I am not an oceanographer, and so I have not made those infographics and designs myself. But there are data that are more localized. Just I think that's where the science is right now.
And again, I can't go super deep. It's a great question, but it also has to do with currents and where the water's moving, how and when. And there's actually, if you're going that deep with data right now, you might be following the AMOC. Who's following the AMOC here? The meridional overturning current, which is up in that region. And that is a huge area of research right now because, well, for many reasons, but there is concern that we could be hitting some tipping points on that, and it's not going to turn over the same way. They got into saltwater versus freshwater, also got into what's melting and how that's interfering. Well, not interfering, how it's mixing or not mixing. And so that's playing into our currents and how that's happening. The huge concern, if the AMOC flips or shuts down, is that regulates a lot of what happens in Europe. And so that's a lot of their weather and their temperate weather, because the reason it's farther north latitudes they have similar temperatures is because of these currents. And so that could play into some huge things for Europe. So that's like really active, crazy, fun research. Depends on who you talk to, what answer you're gonna get, but there's a lot going into that right now.
Anyone else? We have plenty of time for questions.
Not really a question, sort of a comment, if that's okay. I spend my summers here, but I live in California where I'm active in climate politics. You guys are all C3 by the look of it, and I'm from the C4 world. We make noise and are mean. And on the topic of communications, there's an opportunity here in Nantucket and a problem here in Nantucket regarding the wind farm being built offshore and the other wind farms proposed for the area. Those wind farms to me are beautiful and amazing. The whole time I've been involved in climate politics, I've been looking for something with some leverage. I don't feel like I changed the world a lot when I bought a Tesla or decided not to eat a steak one time. But that offshore, which is in danger of being, shut down or dismantled with the cooperation of the federal government, could take 400,000 homes off fossil fuels in one go. And nobody here is advocating for it vocally. It is definitely something that you can get into with a very local conversation. I do because I love to fish, and I've been out to it fishing, and it's full of fish. So I talk to a lot of people I know who are skeptical about the wind farm and advocate as strong as I can for it. So I would urge people here to, find a yard sign, or I'll try and do yard signs or something, wear a button, be willing to quietly indicate, but publicly indicate, that there are people willing to take the risks of wind farms being built off our shore and recognize our responsibility. I come from Southern California. We have a beautiful stretch of water there too, the Santa Barbara Channel. It's full of a forest of oil rigs going day and night. And we'd love to get rid of them. If we don't build wind farms here, we have to keep drilling oil all around California. These energy markets flow one into another. So I would advocate everybody pipe up about that and give the impression that Nantucket is not 95% against there being a wind farm.
I want to say thank you for your comment, and you've made such an important point that these are conversations as a community that we should be willing to have, even if they feel like complicated or hard conversations, or if it seems like a majority of the people that you encounter might have a different opinion of you. That's that piece. It's if we're not having those conversations together and talking through, we're not moving ahead in in any way. So if anyone wants to talk about wind farms, I think we have a convener here that would certainly be interested in making that happen.
Yard signs.
Thank you.
If you want me to make a yard sign. Probably need about one per day.
All right.
Thank you. So when the harbor development occurred up in Boston, there was a big concern that that didn't properly mitigate against sea level rise. Now we face, or not face, but there's this opportunity for development in the harbor area. Here, I think it's called Harbor Square. I'm not sure what that development moniker is, but is the town and are those developers adequately recognizing the risks of sea level rise and mitigating for that development?
Great question. Leah, I don't know if you if there's anything you want to say, and I'm happy to have Giseline pass you the mic. I do want to point out that we have a lot of data here in the town that is focusing on the projects that are happening on our harbor and on our shoreline, is using this data through our coastal resilience plan and through the work of people like Leah who work for the town, and this is their job to make sure that those projects are using the most accurate data that we're able to use and then realistically able to plan for.
Yeah, thanks, Jen. Hi, everyone. So I don't know particularly about that development, but any town projects, especially that are within the coastal resilience plan, we have 40 recommendations in order to mitigate flooding and erosion out to 2070 for critical infrastructure, all incorporate sea level rise and, probabilities and all of that stuff. So in addition, if it's a private property, there's building codes, and those also take into the base flood elevation actually just got increased to incorporate sea level rise and, more intense storms and all of that.
Hi, thank you all. This has been wonderful. My question is for any of you. It's more of, I think it's pretty jarring to see how many of Americans think that climate change is something that we should be worried about, but our governments don't really represent the interests. And so I guess my question is, how would you navigate a conversation between the public and their elected representatives when the actions being taken seem to be completely against the interests of the public? Because there can be a lot of conversations between communities and like the municipal government, but the federal government has a lot of power and a lot of money, and like the EPA protects a lot of the public. The NOAA funds a lot of the research being done, NSF. So it's very disheartening to see that, because it seems like the American people all have a consensus in one way or another, but our interests are not being represented. So how can we reach to those levels that are making the decisions that are directly affecting us?
So you ask a question that's way bigger than climate change. This is a lot of big issues right now. Guns, abortion, a lot of things. So it is a much bigger question. One thing I would say is, other than the president, every election is local. And they have to listen or they're not going to get elected. And that comes in many different ways, right? So climate change really wasn't brought into the last election. So we can't assume, we know what's going on in the federal government with one particular person too, but this wasn't an anti-climate change election, really. Like, it just wasn't brought out there. So I don't want people to just totally cower on that side either and just assume that everyone's against it, because they're not. There's a lot of things people vote for, how they prioritize, a lot of different reasons, right? But every election is local other than the president. And they have to listen to their people. One, it can be tough. I'm not gonna lie. It can be tough, especially since we've known this stuff since the 1980s and more. And so the longer we wait, the more it's gonna cost, the more lives it's gonna take. So you're right. One thing I do have to say for some positivity, right, is look at this room. right? Look at this room. This many people came for this. And we can be force multipliers when we go out there. And the change comes from people. We can't necessarily always just wait, right? It has to come from people who are involved in an issue. It's how all change has always happened in the world. So Greta Thunberg was one person. She didn't even talk. She sat outside with a sign, right? And so look what she created, an entire youth movement. So we can do things. We really can if we decide to do them. It's not going to be easy. I'm not saying it is. I'm not trying to be naive in any of this. But I know that. Another thing, too, is one example of the pushback was, for those who follow the ins and outs, because a lot going on in federal government right now, there was that DOE report, climate report that came out that really challenged the climate science. And it's the foundation for the EPA endangerment fine that they want to overturn. And they just today, there was breaking news before I got here, that they're disbanding that climate team because there was such a pushback from the scientists. Like, I don't know if you follow, but like so many people in my office, so many people literally connected on Blue Sky and created this group of 80 plus scientists who sadly had to spend a lot of their time rehashing misinformation from the 1980s, but put together this massive report that challenged everything that was in that report. And right now, they're disbanding that group. And that's their foundation for the endangerment finding. So,
Yeah.
Just a brief response is a cousin organization of the one that I'm part of, the Massachusetts Conservation Voters. Their whole job, their whole staff is to be on top of who are Massachusetts politicians, what do they do, and are they paying attention to this? We don't always win, we don't always do things right, but you know, they know all the candidates in all the state legislative elections. And that, and you know, calling Bill Keating on the phone, that's a start to making sure public officials reflect what the public wants, should want, done.
I was just going to say that grassroots efforts are historically one of the most effective ways to make eventual change in government. And one of the things that we do here and what we talk about is this idea of having an informed community and an informed public that has this common mindset of what's happening, so that you can then advocate for this is the change we need to see in our community. And us as an island, as Nantucket, we are sitting at that cusp of the possibility of being an example for how a community can respond together. We have a coastal resilience plan. We have people in our government that are actually working on these issues. We have a coastal resilience advisory committee that both Sarah and I and others are on. It's like we are having these conversations all the time and we're pushing things forward. So how do we take it farther and be that example of a community? As Nantucket is a place that you look to for how you respond to these kinds of issues. And that's at least one way that I feel hopeful about how to respond to those bigger levels. And I think Sarah had.
Sarah did. And another thing is you also, businesses, right? They listen to their consumers. So that's another place you can use your voice, what you buy, how you buy, and let them know. Years ago when I'd rent cars, I'm like, do you have an EV? They're like, no. I'm like, okay, well, I want an EV. And they're like, it's just that raising your voice and getting that out there starts to build that.
Yeah, and I would just piggyback on what Bernadette was saying. In addition to businesses, and you're asking for certain things, it's like, we work a lot in the plant space, so it's like at a very small local level, it's like asking for native plants and increasing biodiversity in your yard, and like asking to, for like low water plants, and so that at the very local level you can, make small changes if you have that ability. But then I do, as Jen was saying, our community is, the next level, I would say, your local community. And then we are really fortunate, I find, we're unique because we're a town and a county, so like we kind of skip over that next step. But then as a state, we feel, our government and our state has been really I would say, vocal about their support of biodiversity and climate change funding, and putting their money where their mouth is in those aspects. And so I think to be the example both as an island and as a community, hopefully there's a trickle up. I mean, maybe that's a little more hopeful than reality, but that's kind of what we work towards.
Firstly, great talk, really enjoyed, thank you. Most humans really don't change until something really bad happens, and particularly with climate change because it's such a slow-moving beast. I guess, I'm not sure if this is a question or a challenge. Why can't you model the date or the approximate point in time where things are so bad that we actually all wake up and start doing something? It seems to me you have that data and you could generate some sort of forecast where there's enough of these giant storms and people decide, oh gosh, perhaps we should do something about it. Could you do that?
People have. We are in a really weird space where one person's dominating a lot of this right now. And this is where not just science, but storytelling is really fascinating. So there's this group working with the entertainment industry, from scripted to non-scripted to drama to all of it. And I mean, Day After Tomorrow. There's a lot. There's books out there. There's a lot of this out there that has done this. But even there was what was it? Don't Look Up, right? Yeah. Don't Look Up. Some of them, it's fascinating. I was at a meeting with them, and they do this impact rollout. So when they put it out, they also have a whole campaign on information and how the public can find that information. And so they do open talks in different places and bring it on the road. And so they're trying to. There's this lady that runs a group called Good Energy. And what I've been working on with the journalism and media community, she's done a lot of with Hollywood. And so she does training because they want to represent it. They want to bring it. They want to normalize. Netflix has gone there too. They have a strong sustainability lead. And just to normalize things like seeing an EV, seeing different ways of using energy, seeing solar panels, so it becomes part of the fabric and the background. So there's a few different ways people are going there. People have done it with big storms. People have also tried to use the storms that have happened that are insane. The Sandys, the Helene. I mean, we're getting so many of these every year, and it's still playing out in very weird ways. So I wish I had a better answer for you, but I mean, people have tried that. That's a great question. Once you go there, there's little you can do to go back. There was a really interesting campaign on that the year of the Paris Agreement. So we worked with the World Meteorological Organization, and we worked with TV weather presenters or meteorologists around the world, and they did a 2050 forecast. And they each did it for their country. And it was really fun to watch too, because the type of media you get. In Japan, there was anime on the bottom, and they bow, and then in Bulgaria, our friend there, it was boom, 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 and the world was ending in her video. The Weather Channel did one here. One of our friends who's a meteorologist down in Miami, Spanish language. So there was a whole series of those that went out there. And they did some testing around it, but didn't, not enough to get a sense of what the impact was on people, but it's one of the things. They just did a Cool Kids campaign last year. And again, a lot more of this was international than US, but they had kids do a forecast in that sense of the worst of what's coming, and basically kids were calling out adults, this is what you've given me. And so there was that. You can go find some of those online too. That was a UN campaign.
I mean, to add to that, we've had forecasting that has been, if this level is reached, we cannot backtrack. We've reached those tipping points. We're reaching that 1.5 degree Celsius change in global temperature, and that was forecast a while ago as the piece we didn't want to reach. We didn't want to pass 400 parts, of carbon in the atmosphere. Like, we didn't want to pass that, and then we have. And it's those have gone out there, those numbers are there, but what do people react to? You can show a movie like The Day After Tomorrow and people see it and was like, whoa, that's extreme. But I'm looking outside and it's sunny right now. It's where the change that you're seeing in our daily lives is so slow until it's not. But that idea of if we could tell people, and people are only going to react when we get those highest, craziest storms, we've passed a point of no return on that. We can't back out. So it's like we have to figure out what is the storytelling that gets people to care and react without that extreme piece. And I agree, that's one of the challenges.
Hi, this is following on to your question, and I had a recent conversation with an elected official in Rhode Island, and they brought to light somebody who is doing that calculation, and that is the mortgage insuring industry. So they, in essence, are fast forwarding what does it look like in 30, 40 years? And no, you don't get mortgage insurance. So coastal properties are going to see that happen sooner than anybody else. And that will awaken people if they can't sell or buy a home in a coastal region.
We've been working with insurance companies for years with their catastrophe modeling, and that's a very good point. It still hasn't hit the tipping points you're looking for, and I agree. Because already in California, with wildfires, there's people who can't. Already in Florida right now, there's people who can't. And we're in a weird space right now that's already happening, and it hasn't driven some of the change we like. But it's really important because that's where we're going.
I think the other story we need to tell is the incredibly positive story by doing wind energy, where it's great jobs. And, Rhode Island is doing a lot of this now to say, talking about 400,000 jobs or whatever it is. So we need to do positive because people really don't like telling miserable stories.
You're so right. There's a whole branch called solutions journalism that we work with for this exact reason, because there's amazing stuff going on, like really cool stuff. There's a group, what are they called? The tower climbing grease monkeys. They're mainly guys, but they work on wind turbines, and they have like a whole social media campaign of them up on turbines. It's a lot of people from like out west that are rock climbers, and they're so cool. We've had them on webinars. There's also there's like community colleges in Iowa right now that can't graduate people from some program because all of the technicians, they're being brought in to be technicians. Like, this is such amazing news that's going on. Bill McKibben has a new book coming out, and he's calling a whole campaign in September 20-some, I forget the date, but Sun Day. Not like Sunday in the week, but Sun Day for solar, and all these amazing stories. And one thing I wanted to do, but we haven't gotten the data to do it, is like, what's identified as more American right than you can't touch my energy, right? And I love to do like campaigns of different towns, like put Ann Arbor, Michigan against Columbus, Ohio, and see who could generate more power. Like, there's really cool things we can do with this. And I'm glad you brought that up, because this went negative with some of our conversation, but there's really cool, amazing stuff going on out there.
You mentioned that there was collaboration between science and the legal system regarding legal cases and that were related to climate change. Could you give a couple of examples of what that looks like?
I can't as much, but there is, Columbia's law school is one of the intersections. Georgetown is doing a lot with this too, of bringing attribution science into climate policy. I think his name is Michael Gerard is leading some of that work. There's also the Center for Climate Integrity. My old boss went and started that. And so he's the behind the scenes kind of helping to drive and organize some of this. So they're popping up in different ways. I haven't been in it as much, but I did go to one of the conferences last year, and you could probably even find that agenda. It was Columbia's online of all the speakers they had, because these are the people doing it. So that would be a place to go, and I can help you find that.
Do we have any? Oh, we've got one more in the back.
Hi, so I was just wondering from the fellow's question there, I think I heard that there's a group in California that's suing the power company for the fire it started, right? Is that kind of thing?
Some of it. Also, what was it? The kids. Oh gosh, I'm gonna get the legal language wrong, but it was the kid. Was it Oregon? It was the kids' trust that was behind that one. It was kids suing. It was it Oregon or Washington? It was in the Pacific Northwest of for a fair future. And again, I'm totally gonna mess this up. Montana. Thank you.
Montana, because the state had in its constitution the right to a healthy life, and there are a lot of things one can say about Montana, but the right to a healthier life does seem an appropriate part of the constitution. And the kids sued the state because it wasn't the state government, because they weren't upholding the constitution.
They won. Yeah, they won. They had to go through a lot to get there, but thank you. I'm also going to butcher this. I should probably.
And it was individual kids. Let me add one more thing. They were backed by a climate science group.
The Children's Trust, I think it was.
I thought it was like, it's not the Sierra Club, but it's some equivalent thereof. Meaning, they went to an environmental They went to an environmental organization, but they went as individuals, and a number of these kids had been homeschooled and really had a chance to educate themselves on things they're passionate about, like the outdoors, and became aware of the changes around them. And they were 13, 14, 15 years old, 6 or 7 of them. Fascinating story. They were the ones, the Greta Thunbergs of Montana.
Yes. There was a group of older ladies in Switzerland that had one go through also, and the big international court just had a case go through. Again, I'm totally going to butcher this, but it was one of the small island states, I think it was Vanuatu, maybe you know, who brought this forward and actually won for, as we know, it's not legally binding, but it sets the tone for all international cooperation that this is a fundamental right to a safe and healthy future.
All right. On that positive note, we are going to wrap up our question portion, but we do have a reception that we invite you all to stay for. You can continue to ask your questions and have conversations with each other. Please visit the posters that we have out from our different organizations. We would like to again thank our sponsors for this, the Great Harbor Yacht Club Foundation, as well as the Community Foundation for Nantucket's Remain Nantucket Fund. I'm gonna get that right. And then thanking our organizations as well for supporting this event, the Nantucket Conservation Foundation and the Linda Loring Nature Foundation. We are happy to bring this event to you guys. Thank you.